The NEPHROPS FP7 Project is a collaborative venture between businesses, fisheries organisations and researchers from across the EU. It's funded by the FP7 programme. Its subject species is nephrops, also known as scampi or langoustine, one of the most important shellfish stocks in European waters. The aims of the project are to develop low-tech hatchery technology that could be used by SMEs and procedures that will improve the sustainability of the fishery, for example by improving discard survival rates. In order to work on the animals effectively, the project has taken advantage of the extensive expertise and facilities available at Gothenburg University's Marine Research Station in Christineberg.
When you hold them, if you hold them like that, then it's like when they're in the rubber, so they press their tail towards your hand. And they are maybe not happy, but they are content with being held this way. You will have a snipper, which is slightly slender and have this. Then we have the crusher, which is thicker and has a lot of teeth on it. They mainly use their big claws to dig. So they push the claws through the sediment like a bulldozer.
In the lab, egg-bearing females are maintained in isolation tanks until they release their larvae into the water by adopting a characteristic stance with their tail raised and fanning the water with their pleopods. The released larvae are planktonic, and in the lab they're fed on brine shrimp until they reach the post-larval stage. After development in the hatchery, or for release of animals discarded by fishermen back into the wild, it's important to know how the animals fare on the seabed and that the release procedure is optimised to maximise survival. Several release methods have been trialled, including just releasing animals from plastic boxes or from industry-standard storage tube boxes. When taken to the sea floor in tube boxes, many of the animals appear quite content to stay put. There are observable differences in behaviour depending on whether animals are released into habitat that already contain nephrops burrows or uncolonised seabed. On uncolonised, unsuitable habitat where there are no burrows, they may spend time wandering around on the surface, become involved in aggressive interactions with other released nephrops, or fall victim to other resident fauna seeking an easy meal. On suitable habitat, however, the animals appear to quickly find their feet and display normal behaviours such as finding a new burrow, investing it in case there's an occupant present already by entering it head first. If all is clear, they're often observed backing out of the burrow, rapidly turning around and then reversing back into it. Once established in their new home, they will adopt the gatekeeping behaviour commonly observed in the species. When a new animal encounters an occupant in a burrow, both will display a characteristic interaction that involves spraying urine in each other's faces and tapping calipeds to assess the strength of the opposition. When the animals were monitored for 3 days after release, it very quickly became clear that on suitable ground, animals are accepted by the resident population and become incorporated into the matrix of existing burrows. It was clear that females were able to find a burrow more quickly than males, and that after 3 days only some males were still visible above the surface.